So in this video, I'm going to be covering 5-2 part 2. Again, this is actually the second video to the first one. So in this video, the primary concept or content is we're going to be covering binomial parameters, formulas. So these formulas only applies to binomial when you have a binomial distribution. So if you do have a binomial distribution, again, refer back to the previous video for the conditions to which you it would tell you when you're in a binomial distribution, then you can use this formula. So you can use this formula to find the mean, you can use this formula to find the variance, and this one to find the standard deviation for a binomial distribution. All right, so problem number 1, I'm just going to jump right into doing some practice problems. It says, according to a report, 38.4% of working adults in the U.S. hold a college degree. Find the mean and standard deviation who hold a college degree for a sample of 28 randomly selected adults, working adults. All right, so we have a sample of 28 adults, and we want to figure out, well, what's the mean number of adults with a college degree, right, that we would expect with a college degree. And because this is a binomial distribution, again, how do we know that? The most important requirement that you have to check is that there's two category outcome. So when you select an adult, they either have a college degree or they don't, right? So that is what makes it binomial. There's that two category outcome. They either have a college degree or they don't. All right, so given that, we know that, well, let's identify n in this case is 28, and let's identify p. So p is the probability of success. So success in this problem, in this situation, is if an adult has a college degree. So in this case, that's 0.384, and pretty much I just turned that percentage into a decimal. And you're also going to need Q, because that goes into the calculation of sigma, the population standard deviation. So Q is always equal to 1 minus P. So that okay, so we get the following. We get 1 minus 0.384, which is 0.61, or 0.616. Sorry, so 0.616. All right, so we have everything in that we need. So the formula for the mean for a binomial distribution is n times p. So that's going to be 28 times 0.384. And the formula for sigma, the population standard deviation, is equal to the square root of n times p times q. So q is 0.616. All right, so let me show you guys how to input these two into the calculator. So we have, let's see, we have the first one is 28 times 0.384. All right, and then the instruction says to round to 1 decimal place if needed. So that's going to be 10.8. And then the second one, we're going to call the square root function. So the square root is right above the x squared in blue. So we're going to press second x squared. And then we would just input our numbers, right? 28 times 0.384 times 0.616, just like that. We could put parentheses as well. I just chose to put the multiplication sign. Either one is fine. All right, so enter. So rounded to 1 decimal place, that's going to be 2.6. All right, let's move on to number 2. So number 2, we have McDonald's has a 95% brand recognition rate. A focus group consists of 12 randomly selected adults to be used for market testing. For such random groups of 12, find the mean and standard deviation for the number of people who recognize the McDonald's brand. All right. So same thing, right? N in this case is 12. P is 0.95, right? We're going to change this percentage into a decimal. And then Q is just 1 minus P, right? So For the mean, we know that's equal to n times p, so that's going to be 12 times 0.95, which gives us 11.4. And for the standard deviation, we're going to get, it's the square root, right? So square root of n times p times q. Q is always 1 minus p, so that's going to be 1 minus 0.95, which is equal to 0.05. So rounded to 1 decimal place, we're going to get 0.8. All right, and then this question further says, would the following number of people recognizing McDonald's be considered significant? All right, so in other words, is this significantly high, significantly low, or if it's not significant at all, right? So we're going to use both methods just to get practice with both methods. And so when I mean both methods, I'm talking about using the range rule of thumb and using probabilities. So let's go ahead and look at the range rule of thumb first. So the range rule of thumb states, I'm just going to put it as range rule, but we understand it's range rule of thumb. So range rule of thumb states that any value, we have a minimum value and a maximum value for the significantly low and significantly high, right? So those numbers are, let's see, we have the sig low value, which is 2 standard deviations below the mean, right? So 2 standard deviations below the mean. So remember, refer to your notes in the prior section or the prior 2 pages of your notes for the range rule of thumb and probability using those two, right? So significantly low is 2 standard deviations below the mean or lower. Significantly high is 2 standard deviations above the mean or higher, right? All right, so given that, let's figure out those 2 values. So for the sig low value, that's going to be the mean minus 2 times the standard deviation. Again, oops, I'm messing up my 2 values here. So for this problem, let's clear this all out. For this problem, the mean is 11.4 and the standard deviation is 0.8. So 11.4 minus 8, 2 times 0.8. And then the sig high value is just plus, right? The mean plus 2 times 0.8. Okay, so those are our 2 values. So we have the sig low is 9.8 and the sig high is 13. And we know the range rule of thumb says the sig low value or lower, or that value or lower, this would be your significantly low values, and then 13 and above would be significantly high. And again, this is if we randomly select 12 people, 9.8 or below would be considered significantly low. 13 and above would be considered significantly high. Now you might say, well, how can I get 13 people out of 12? The thing is you can't, right? But then it is what it is. The range of thumb gives us those 2 values. So you can see that out of 12 people, if you get all 12 people recognizing McDonald's, that would not be significant at all. That wouldn't be significantly high at all, because it's just McDonald's is such a widely recognized brand that you wouldn't be surprised or you wouldn't think it's significantly high if all 12 people recognize McDonald's, right? Again, if you're using just like common sense thinking. Okay, so 12 people, would that be considered? What would that be considered? Well, let's see. We know we expect 11.4 people to recognize McDonald's, right? The mean is the expected value for 12 people, but 12 is higher, but is it significantly high? Well, no, it's not, right? So we know that it's not significantly high or not significant. What about 11 out of 12 people? Well, let's see. 11 is less than the expected value, which is 11.4, but is it significantly low? No, it's not. So we know that it's also not significant. What about 9 people? So let's see. 9.8 is the kind of like the cutoff point for significantly low. And anything below that would be significantly low. Or anything 9.8 and below would be significantly low. So 9 is to the left of that. It's in that range. So we know that that's significantly low. All right, so that's using the range rule of thumb. So now let's move on to using probabilities to determine whether something is significantly low. So with probabilities, we know that we need to first kind of look at where that number is in relationship to what we expect. So for example, the first thing is we know we expect 11.4 people to recognize McDonald's when 12 people are selected. So is 12 significantly high? 12 is higher than 11.4, but is it significantly high? So using we also know that to determine whether something is significantly high, we need to find the probability of that number or higher. Okay, so 12 or higher, we got to find the probability of 12 or higher. So we need to figure out. We know this is binomial, so we know we could use binom PDF or binom CDF. Okay, so here I've written the possible number of people who can recognize McDonald's, given that 12 people are selected, right? You can have no one recognize McDonald's all the way to all 12 recognize McDonald's. So to calculate the probability of 12 or higher, it's essentially just calculating the probability of 12 because that's the most we can get. So we can use binom PDF for this problem. So we're going to use binom PDF. So we're going to go second vars and go to binom PDF. And the number of trials is 12. P is 0.95, right? That's the probability that someone recognizes McDonald's, which is 95%. And then the X would be 12. And then paste. And that's the probability that 12 people, 12 or higher, recognize McDonald's. That's going to be 0.5404, which is definitely higher than 0.05. So we know that it's not significant. So we get the same result, not significant, when using probability. Question B. So question B is we're looking at is 11 significant? Well, 11 is less than 11.4, which is what we expect. So, but is it significantly low? So determine whether something is significantly low. We're going to find the probability of 11 or lower. All right, so 11 or lower, we can use binom CDF, right? So again, we're looking at the probability of 11 and to the left. So we're going to use binom CDF. So we're going to go second vars. Binom CDF. So number of trials is 12. Probability of success is 0.95. And whatever value we put into this X value, that's going to calculate the probability of that number or below, which is, in this case, we're looking for 11 and below. So we're fine to use CDF and knowing that this is going to be our answer, right? So that is going to be our answer, which is approximately 0.4596. Which is definitely greater than 0.05. So in other words, when the probability of a result is not smaller than 0.5, or in other words, it's high, then we say it's not significant, right? Only when a probability of a result is very small are we going to be surprised and say that it's significant, right? Just like if you flip a coin 100 times and you get 99 heads, that probability should be very low because that is a very surprising result. To get 99 heads out of 100 flips when you expect around half of it to be heads would be very surprising, and then in that case significantly high for 99 out of 100 heads. But in this case, because 11 people out of 12 it's not significant because the probability is not low. In other words, it's high. All right, and then finally, for question C, of using the probability, we want to determine whether 9 out of 12 people is significantly low. Why significantly low? Because 9 is less than what we expect. So it's lower than what we expect, but is it significantly low? That's the question we're asking. So we need to calculate the probability of 9 or lower, right? Again, if you don't understand why I'm looking at 9 or lower here and 11 or lower here, and then 12 or higher here, refer back to the chart that I showed you guys on using probabilities. Again, you're always looking at in relationship to the expected value. Like, where does this guy stand? Like, where do these numbers stand? 9 is less than 11.4, which is the expected, but is it significantly less or significantly lower? And that's what we're trying to calculate. And to calculate that, we need to calculate the probability of 9 or lower. All right, so 9 or lower is, let's see, what does that mean? 9 or lower is 9 or less to the left. So we know we're going to use, we know anytime we're calculating the probability of more than one event, we're always going to use CDF, right? Binom CDF. So we're going to go second bars, binom CDF, and then that looks good. This looks good. And then we're just going to change this to 9, paste, and we get the following. So we get approximately 0.0196, which is less than 0.05. So the probability of getting 9 or lower, 9 or less people recognize a McDonald's is pretty low, less than 0.05, right? Less than or equal to 0.05, which means it's very unlikely to happen by chance, which means it's significantly low in this case. Again, significantly low because 9 is less than 11.4. All right, so that's that. For this one, you guys can go ahead and try this one on your own. And that concludes that. So actually, I'll go ahead and do this problem just so you guys can see how it's done. Just get a little bit more practice on your end. So I encourage you to pause the video to work it out yourself and then come back and watch how I do it. Okay, so here's how you do it. So based on a poll, 25% of adults believe in reincarnation. Actually, let me change that to yellow highlight. Assume that 37 adults are randomly selected. Find the mean and standard deviation who believe in reincarnation among 37 adults. All right, so we know this is binomial because the outcome is you either believe in reincarnation or you don't believe in reincarnation, right? So this is my P, this is my N, and my Q is just 1 minus P, right? So for my mean, the formula for a mean, given that it's binomial, is going to be N times P, so that's going to be 37 times 0.25. So rounded to 1 decimal place, that's 9.3. And then the standard deviation is the square root of N times P times Q, which is 0.75. Now, how did I give 0.75 for Q? Well, that's always 1 minus P, so that's 1 minus 0.25, right? That's how I got the 0.75. All right, oops, let's go back to that. Okay, so we're going to evaluate. So we're going to get approximately 2.6 for our standard deviation. So using the range rule of thumb, the range rule of thumb, so let's call that range rule. So we know that we need to find that minimum or that significantly low value, right? The cutoff point for significant low, and then the significantly high. All right, so the significant low is 2 standard deviations below the mean. So in other words, we're going to take the mean and we're going to subtract 2 times the standard deviation. So that would be 4.1. And the significant high value, or the cutoff point for that, would be 2 standard deviations above. So that would be 14.5. So we know that anything 14.5 to the right is significantly high number of people who believe in reincarnation out of 37 people, and then 4.1 or below is significantly low number of people for when you randomly select 37 people, right? So let's see where these guys fall. So like 20 is over here, so that's significantly high. So 20 is sig high according to the range rule of thumb. 13 is somewhere in here, so that is not significant. So this is not sig. And then 4 is a little bit to the left of 4.1, so that's in the sig low region. So that's what we have there. Now, I understand that using the range rule of thumb is very simple compared to probability, right? But again, later on, probability is going to be the main way we're going to use to determine whether something is significantly low or significantly high. So get comfortable with using probability as well. Okay, so for question A, we have 20 adults out of 37. So 20 is higher than what we expect. Again, for probabilities, the mean is the expected value. So we expect 9.3 people on average out of 37 people to believe in reincarnation, according to all of this stuff right here, right? According to this information. So 20 is higher than 9.3, but the question is it significantly high? So in this problem, we have to calculate, if we want to determine whether it's significant, we're calculating whether 20 is significantly high, right? And we need to calculate the probability of 20 or higher. Well, let's see. So the number of people possible for believing in reincarnation when you randomly select 37 adults is 0 through 37, right? You can have no one believe in reincarnation all the way up into 37, all of them believing in reincarnation. And we want to find the probability that 20 or higher, the probability is 20 or higher. So 20 is somewhere here, or higher would mean that 20 or above. And given that this is binomial, we know we can use either binom PDF or binom CDF. So we know we're not going to use PDF because binom PDF would be for a situation where we're looking at the probability of the exactly 20 or exactly 1, right? But that's not the case in this problem. We're looking at 20 or higher. So we know we're going to use binom CDF. But there's a problem, and I'll explain why. So the number of trials is 37. Probability of success is 0.25. There's a problem because the way that binom CDF works, or the way that it's programmed, is whatever value you put in here it's going to calculate the probability of that number or below. So let's say I want to put, let's say I put 20. I mistakenly put 20, which is a common mistake a lot of students make. When you're trying to find the probability of 20 or higher, a lot of students, they put 20. Why is 20 not the correct answer? Because essentially when you put 20 in there, what it's going to calculate is the probability of 20 or below. That stuff in the blue, which is not what we want. We want 20 or higher. So how can we figure this out? How can we calculate this? Well, what you need to do here, whenever you're trying to calculate the probability of a number or higher using binom CDF, you need to calculate the complement, the probability of the complement, which is what I have in which is what I shaded in blue, right? So you're going to calculate the probability of the complement, and this is not your answer. So to get your answer, you need to subtract from 1, right? We need to use the complementary probability complementary formula, which is the probability of A is equal to 1 minus the probability of its complement. So we're going to go 1 minus that right there. And so we get, again, this is scientific notation, meaning that we're going to move this decimal point 1, 2, 3, 4 times to the left. And the result is approximately 0.000301. I'm running to 4 decimal places. All right, and definitely this is less than or equal to 0.5, which means using the probability, we also get that it's significantly high. We know that it's significant. Why is it significantly high? Because 20 is more than what we expect to get. All right, let's go for the question B. So the question B, we have 13. So 13 is also higher than the mean, but then we have to ask ourselves, is this significantly high? So 13, so we're going to calculate the probability of 13 or higher, right? So let's go ahead and, so similar to how we did with the 20, here's 13, and we know we're trying to find the probability of 13 or higher. But then because the way that binom CDF works, it cannot calculate the probability of a number or higher. So we have to find the complement first and then subtract from 1. So let me show you guys another way of doing this. It's just a small shortcut. So we know when we go to binom CDF, we're going to have to put in 12 and then subtract from 1. A little shortcut, and again, this is a little bit of a time saver. It's not too much. You can just go ahead and put 1 minus and then navigate to Binom CDF, and it would give you the answer without you getting the answer and then subtracting from 1, right? So doing this, and then we're going to go to second vars, Binom CDF, and then change this to 12, right, which is a complement of 13 or more, right? So this is going to calculate the probability of 12 or less, and that's our answer right there. So we get approximately 0.11, oops, change that, 0.1109, which is greater than 0.05, which means it's not significant. Again, this is my answer because when I inputted, I did the 1 minus already. So I could have done Binom CDF, right? I could have done the following. Put 12 in there and get that answer, and then do 1 minus that, right? I could have done that as well. So either way, if I put in the 1 minus and then navigate to Binom CDF, that's fine. Or I could have used Binom CDF and then subtracted from that, and that's fine. So just kind of recap, you only do the 1 minus, like we did here, if you're trying to calculate the probability of a number or higher and you're forced to find the complement first. That's only when you do the 1 minus. But anytime you're trying to find the probability of a number or less, you do not need to do the 1 minus. For example, in the next problem, you do not need to do the 1 minus, and I'll explain, you'll see why. So for question C, we're trying to figure out whether 4 is significant. And since 4 is less than 9.3, which is what we expect, we have to ask the question, is it significantly less? And to ask that question, we need to calculate the probability of that number or lower, right? So because we're trying to find the probability of 4 or lower, so let's see, we have 3, 4, 5, 6, and so on. So because we're finding the probability of 4 or lower, we do not need to do the 1 minus when we're using Binom CDF. Why is it that we don't need to? Because let me show you why. So let's go to Binom CDF. Because whatever value we put in for x is going to calculate the probability of that number or less. And that's exactly what we want. We want to calculate the probability of 4 or less. So we don't need to do the 1 minus because we don't need to find the complement or anything. That it's going to figure things out directly. So the probability of that is 0.0284 approximately, which is less than or equal to 0.05, which means it's significantly low. It's significant because the probability is small, right? Less than 0.05. And it's significantly low because this 4 is less than what we expect. All right, so hopefully you guys found that helpful. One other note, and I mentioned this before, I believe, but I'm mentioning it again here. This 0.05 later on, that is going to fluctuate. So sometimes we're going to be using 0.05. Sometimes we're going to be using something smaller. Sometimes we're going to be using something higher as our cutoff point, depending on the situation. And I just want to warn you guys ahead, but for now, 0.05 is our cutoff point for probability to determine whether something is significantly high or low. But later on, just know that it's going to fluctuate. All right, so if you have any questions, let me know.